Welcome to Siren Tribble YouTube channel. Let us discuss the Model 5 research areas and professional development and project exhibition demonstration. The introduction part of research education are research areas in the smart grid. The smart grid will require engineers and professionals with a greater expertise and training than the skilled workforce of today. So we want the smart grid needs uh, more number of engineers and professionals with a greater expertise and experts we want, right? So that's a research areas or research professional development. In addition to the technological aspects development, engineers will need to study manufacturing, data management, asset optimization, policies, and protocol development. Say engineers in one line, engineers needs everything so engineering in the sense like what design new things or design new machine or design who one who design an engine is called as engineers in 1846 in the Google they mentioned, right? So study manufacturing and see engineers involved not only electrical in the sense electrical areas particularly core areas we are involving every areas, and instead of doing electrical work we were doing um, I mean software works are so the plenty of opportunities are will be available nowadays, right? The smart grid will also depends upon expanding current research effort in the areas of cyber security, control, communication, computational intelligence technique, and decision support tools. See, smart grid not only involves electrical power supply system from the transmission lines to generating station to your home. It includes several aspects, like several parameters included. One is cyber security. So everybody knows, right? How the cyber crime or cyber security will be developing in the world and in India also. So there is a separate cyber security department will be there, and there so many are experts will be involving, and then they are concentrating particularly for cyber crime or it involves so many like without knowingly it will be happening, right? So it's outside the our thinking. So what is happening in the media, or what is happening in the uh, inside communications, right? So next there is a controls. So here controlling part also will be there. So if, I'll just go to power supply system. So controller is required. Power supply controlling or I mean management control are so for smart grid is a extended expanding and then extended research, right? So and also communication. So now if suppose if you heard that communication word, it'll go to electronics and communication department, right? So that is wrong actually. So in this smart grid we have a communication also. Say if suppose power generation is this much and then power utilization is this much, how will you communicate, and then how will you get to know how much power is required, or if suppose you people are thefting the power supply system, what so how will the power system department will come to know you are thefting the power supply and then you are misusing. So communication must be there in the transmission lines also, and in between this controlling rooms also, right? So and then computational intelligence techniques, right? So smart grid is uh, the name itself indicates smart one. So definitely intelligent power supply system from the generation to the consumer side. So intelligence computation so several areas will be there. So see here research if you want to do you'll get lakhs together areas, right? So and decision support tools, and then decision support tools also will be there in the smart grid, right? Next we have smart grid research areas for a smart grid development. Work is underway developing research support for intelligent grid facts, technology and coordination and placement, real-time applications, and then PMUs for a real-time voltage stability and reliability monitoring and control. See, smart grid will monitor continuously with respect to power generation, power utilization, and then power transmission, and suppose some anything abnormal condition occurs, that will also monitor. So this one is a like monitoring the power supply system. So uh, my request for the students is, first you must understand what is smart grid. So you will get to know, I mean like will I mean understood definitely I am sure all the concepts of model 1 2 3 4 5. So first we must know what is smart grid, and then how it works, and what is the key features, and what benefits if you implement the smart grid, that you must know, right? Next, other research includes advanced distribution automation capable of handling distributed DSM, I mean demand side management functions with the real time pricing options of mechanism. See, other research in the sense like distributed automation, like, so if I go to distributed generation, for example, our college top I mean like rooftop, there is a solar power plant, I think everybody knows, right? So that is a distributed generation from the college to the government, right? So how the automation will be occurring, and then how the power supply will go to government, and how it is coming from back to the government, and if suppose there is a number of distributed generating stations will be there, like wind, hydel, thermal, or nuclear, or several I mean, generating stations will be there. So how the power plant will works, and then how the automation will works, and then distribute, I mean demand side management. So how the management I mean like demand from the consumer, how it will be managing, and if suppose for example I'll tell you demand side management. So if suppose I am demanding 20 uh, megawatts power supply, but the availability is 12 or something else, right? So how they will manage that demand side management? Otherwise, if suppose I need a instead of uh, 2 kilowatts, I need more than 4 kilowatts. So how they will fulfill the customers, and then that also includes smart grid, okay? And with a real time pricing and options and mechanism. So real time pricing and real time mechanism, okay? So this will include here. uh, Next we have a smart grid deployment. So this is a problem, okay? And classical method, this is one of the methods: stability classical method, QC steady state modeling, and see here there is a improvement current for a static model, right? And a recommendation for a smart grid deployment. So this is a stability, and this one is a OPF, and economic dispatch unit commitment and reliability. So here there's some methods will be there. Leftovers method, transient energy functions. These are the methods. Eigenvalues, interior point method, trust region method, minimum cost while meeting the constraints, state enumeration, effects of analysis reliability include. So these are the methods of to solve the problem. And improvement, QC state, steady state modeling, and SQP and SQF. So variant of nonlinear interior points method, probabilistic input data reliability study. This is the study improving current static model, and a recommendation of smart grid deployment. So a real-time computation using learning algorithm ADP for a control coordination, index for a fast and accurate evaluation, and a knowledge-based system, computational intelligence method to accumulate for certain randomness. Computational intelligence and its hybrid method together with the dynamic in the data. So these are the concepts we're going to discuss now.